In this video, I'm going to show you how to find the absolute maximum and minimum values of any function. So now we're given the equation f of x equals x squared plus 4x plus 1 on the interval of between 0 and 3, and we're wanting to find the absolute maximum and minimum values. So there's a few things we have to do. The first one, I'm just going to put this 1 here, is to evaluate the function on the endpoints. So we're going to find f of 0 first. And if we plug in 0 here, we will see we'll just end up with 1. And we'll want to also find the other endpoint. So if we plug 3 in here, we will get 9 plus 3 times 4 is 12 plus 1, which is 22. The second thing is we're also going to want to evaluate our function at the critical values or the critical points. So to find the critical value, we'll have to take the derivative of our original function, which is just 2x plus 4. And to find the critical value, we just have to set it to 0. So through rearranging, we get that x equals, well, minus the 4 over divided by 2. So x will be negative 2. But you'll notice that this negative 2 actually fits outside of our interval. And since it's outside, we don't consider it. So even though it is a completely valid critical value, it's not in this case. And that's about it. We just have to evaluate at those few points. So we see that the absolute maximum is our greatest value, which is f of 3. So our absolute max is f of 3. And you can also write f of 3 equals 22. And then the absolute minimum is our f of 0 equals 1. That's all that is. Our next example is now a basic trigonometry example, and we're being asked to find the absolute maximum and minimum on the interval of 0 and pi. So, as we did before, we'll need to do two things. We'll need to evaluate on the endpoints and then the critical points as well. So, if we do the endpoints, sine of 0 is just going to be 0 plus, and then cos of 0 is actually 1. And so f of 0 is 1. If we, that's a bad f. If we then do f of pi, if we evaluate sine at pi, we also get 0. And then if we evaluate cos at pi, we actually get minus 1. And so our final value for f of pi is minus 1. And if you're curious how we found these, you can just draw out the graph of cos and sine. And here is our sine and cos. So you'll see the areas that sine is 0 and where cos is. So when sine is 0 at 0, this is 1. And then here is our pi. So maybe I'll just write that quickly. And then there's our 0. And you can see that cos is minus 1. Next, we're going to want to take the derivative to find the critical value. And so f prime of x, or the derivative of f of x, is sine becomes cos. And then cos actually becomes negative sine. And now we want to find where this actually equals 0. And so we'll want to actually find where that sine and that cos on this interval are actually equal to each other. And you'll see at one point they actually are. And if you use the unit circle over here, you'll see that at 45 degrees or pi over 4, that sine and cos are equal to each other. So our x value is going to be pi over 4, which does fit in our interval. So we need to evaluate this in our original equation. So f of x equals pi over 4 equals. And so from before, we know that sine and cos are going to be the square root of 2 over 2. So let me write that real quickly. Which will equal 2, square root of 2 over 2, which will just equal the square root of 2. And this is actually going to be greater than our 1. So the critical values of our function is not, or sorry, the absolute maximum is not going to be 1. It's actually going to be when the critical value is. So our absolute maximum is when f of x is f of pi over 4, which equals the square root of 2. And our absolute minimum is at f of pi, which is equals minus 1. So for our last example, we're given the piecewise function f of x equals x squared plus 1 in the intervals between 0 and 1, and 4 minus 3x in the interval between 1 and 2, not including the 1. And we're being asked to find the absolute max and min again. So similar to before, we're going to want to evaluate f on those endpoints. So f of 0, because 0 is in this interval, we're going to be evaluating this equation of the piecewise function, which is just going to be 0 squared plus 1, which is just 1. And then we're also going to be evaluating f of 2. And because 2 is in this interval, we'll be evaluating this equation in the piecewise function. So this is going to be 4 minus 3 times 2, which is just 4 minus 6, which is just negative 2. Next, we're going to want to find all critical points of our function. So for differentiating a piecewise function, what you're going to do is take the derivatives of each separately. So the first equation is going to be 2x. And you'll actually notice I am not going to include that equal sign. So this is going to be x less than 1. Because these two functions join at 1, we didn't test for continuity, and therefore we don't even know if it's differentiable at 1. But because this is a polynomial function, we know it's going to be differentiable on the entire interval except for that one point, because it could be a discontinuity there. Again, we're going to do the same for the second. So 4 minus 3x is just going to be negative 3 between that same interval, 1 less than x, less than or equal to 2. And so looking at the first equation, we can see that there is a point at which our slope is 0, and that's going to be for when x is 0. However, we already have our f of 0 equals 1, and so while our critical points, let me write that a bit better. And so while our critical points are when x equals 0, we've already evaluated that, and so we know when that f of 0, or what that f of 0 is going to be. Looking at the second equation, that negative 3 is a constant slope, it's just a constant, and so there's going to be no point on this curve that this negative 3 is going to be 0. However, there's one more place we need to check, and that is for when f equals 1. So for something to be differentiable, it does need to be continuous. And so if we evaluate f of 1 on both of these equations, they should equal each other, or else the derivative does not exist. So I'm going to call this equation 1 and equation 2. So our f of equation 1 is just going to be 1 squared plus 1, which is going to be 2. And our f of 2 is going to be 4 minus 3, which is just equal to 1. And these are actually not equal to each other. And so this is not differentiable at this point. However, even though it's not differentiable, the definition of a critical point is when the derivative does not exist. And so our critical point is also going to be x equals 1. And we've actually already found our f of 1, because 1 is going to be included in this equation. So we're going to evaluate f of 1 here, and so this is going to be our one of our equations we're going to be looking at. And so we actually see that that is going to be our absolute maximum between f of 0 equals 1, f of 2 equals negative 2, and f of 1 equals 2. The highest value is when f of 1 equals 2. And our absolute minimum is when x equals 2. So f of 2 equals minus 2. And that's our final equation. And that's how to find the absolute maximum and minimum of any function. Leave a like, comment, and subscribe if it helped.